In this video, we're going to look at how do we actually construct that confidence interval for a population standard deviation or for a population variance, for those values of sigma or sigma squared respectively. So let's remember notationally some things that will be important here. So remember sigma, that is a population standard deviation. And S is a sample standard deviation. That value of N, that is our sample size. And those are the pieces of information that we need. You might have S squared given to you, that is just your sample variance, or sigma squared, that is your population variance. In StatDisk, this is how we would proceed through this process. So we would first check that the following requirements are satisfied. The sample is a simple random sample, and the population must be normally distributed even if N is large. If we don't have a normal distribution, the things that we do in this setting, the things that we do here, this confidence interval, it will be meaningless. So the population must be normally distributed even if N is large. All right, so once we have that, we want to identify the confidence level. We want to identify the sample size and identify that sample standard deviation. So we're going to identify those three things. We will choose analysis, confidence intervals, and then standard deviation one sample. Even if we're trying to, if our goal is to construct a confidence interval for a variance, we're still going to choose standard deviation one sample in StatDisk. Then we input those three values we identified above, the confidence level, we input the sample size, and the sample standard deviation, and evaluate that. So let's take a look at an example. A random sample of 40 Chips Ahoy cookies found that the mean number of chocolate chips was 24 chocolate chips and a standard deviation of 3. All right, so here we have our sample size, 40 is given. That's our sample size. That's our 40. The study found that the mean was 24. So that is the mean for the sample, our sample mean. That information is not actually important to us when we are trying to construct a confidence interval for standard deviation or variance. That's just extra information, but not important to us. This sample also had a standard deviation of 3. So that standard deviation of 3, that is the sample standard deviation. It is in this sentence dealing with the sample information. All right, so if I were to jot these things down, we have right now N is equal to 40. That's our sample size. We have sigma is equal to 3, not sigma. It's a sample standard deviation. S is equal to 3. All right, so first we're going to find a point estimate for the standard deviation and the number of chocolate chips in all Chips Ahoy cookies. And so a point estimate would be, let's say that it is 3 chocolate chips. So we said the standard deviation in the sample was 3. If we're going to pick a point, we might pick that value. Now remember, we have a biased estimator here, so that's maybe not even the best value, but that's the value that we're going to choose here. Next, we're asked to calculate a 90% confidence interval. So 90% confidence interval for the standard deviation of chocolate chips in all Chips Ahoy cookies. So we're going to go to StatDisk. Remember, our sample size is 40, and S, the sample standard deviation, is 3. we're going to go to StatDisk and we are going to construct this confidence interval in StatDisk. So here in StatDisk, we're going to choose analysis. We're going to choose confidence intervals. We're trying to come up with a confidence interval for a standard deviation with just one sample. Right? So that's what we're going to choose, standard deviation, one sample. And we need to input three different things. We need to input the confidence level, which here is 0.90. We need to input the sample size, which here is 40. And we need to input the sample standard deviation, which here is 3. Once we have those three pieces of information, we can evaluate, and this will spit back the confidence interval. Actually, it will spit back two confidence intervals. Right? So one confidence interval that it spits back, the first one is for standard deviation. That's what we are interested in this problem. But if we wanted a confidence interval for variance, that is also provided there. Right? So that's right down below. All right, but for us, we have 2.536 to 3.696. So 2.536 to 3.696. So that is our confidence interval for the standard deviation. What we are saying there is we are 90% confident that the interval from 2.536 chocolate chips to 3.696 chocolate chips actually does contain the true population standard deviation. We think that the standard deviation is living in that range of values. We think that that range of values actually captures the population standard deviation. For our margin of error, that's actually not a good question. We don't really have a margin of error here because our point estimate is not going to be right smack dab in the center. Notice that our point estimate here was 3, and so to the left of 3, we go down like 0.464. To the right of 3, we go up 0.696. So that value of 3, it is not central. It is not the middle of our interval. Again, that's because this is not the best point estimate. It is a point estimate, and we use that to help generate everything else. All right, so can we confidently say that the standard deviation is greater than 2.4? So can we say that confidently? Yes. Why? The entire confidence interval that we came up with up here, that entire confidence interval is above 2.4. Can we confidently say that the standard deviation in the number of chocolate chips is less than 3.4? So can we say that that is less than 3.4? No. Why not? 3.4 occurs somewhere in the midst of this confidence interval. So there are values that are more than 3.4 that still live in that confidence interval, and there are values that are less than 3.4 that live in the confidence interval. So because of that, we cannot confidently say that it is less than 3.4. So that confidence interval, it contains values both above and below 3.4. That's why we cannot confidently say that it's less than 3.4. Even though most of those values are less than 3.4, even though we got a sample that had a standard deviation of 3, when we build out that confidence interval, it contains values that are bigger than 3.4. So we cannot say that with confidence. All right, In the next video, we will take a look at trying to determine sample size for standard deviations and variances. We'll talk to you then.